We are live. Let's open up the chat window. Clear to go. Okay, tonight. You may have noticed that Keras 1.0 just came out on Monday, yesterday. I was not able to stream last night, unfortunately, on it. But we're here tonight. We may look at some recurrent neural networks, but I first want to poke at introducing Keras 1.0. I didn't actually realize that we had been using point whatever, and it wasn't not only at 1.0. I thought it was pretty good before then. So this is super cool to hear. The developer, Francois Cholet, I apologize for mangling your name, just put up a blog post at blog.keras.io introducing Keras-10, talking about stuff. To me, the biggest change that looks like happened is he's got what's called a functional API instead of the graph API. You may have noticed there's now sequential and functional. And so functional replaces the graph, which is sort of a general connection of things. Sequential is what we've been using before, where you just have one layer, fully connects to the next layer, fully connects to the next layer, so on and so forth. Other things, he claims there's better performance. That's good to hear. All RNNs now come in 2 different implementations to choose from. Ooh. Modular metrics. You can now monitor arbitrary lists of metrics on arbitrary endpoints of your Keras models. Interesting. Even better user experience. Code rewritten from scratch. That's dangerous. Intuitive APIs. The kinds are easy to memorize. Interesting. Improved lambda layers. I didn't fiddle with lambda layers. You can install the new version from PyPy. This is what we're going to do. I have not done this yet. We're going to do it. Or clone the master branch. Yeah, I'm not cloning the master branch. Let's do it. Boom. Let's see if it's available in Python 3. Boom, 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 boom. Look at that. I'm not sure why it's filling up the whole screen. Oh, probably because it doesn't realize how wide or not wide this is. If I, oh yeah, look at this. Nice and pretty, right? Gotta download that, install, run setup. We might go back to the Keras basics just to poke around stuff first. Tab new Keras tutorial. There we go. Is this what I made, or is this what someone else made and I just copied it? This is what I made. Anytime you use a matplotlib to do silly things, that's clearly my work. Convolutional layers. So we're gonna see how much of this is the same, how much of this is different first. And then we'll go back and check the RNN, which I was just filling with again. Was not getting it to work, but that's okay. We'll go back to that. Man, this setup takes a while. See what happens. See what happens. I really was not expecting this to take this. I should have learned my lesson and installed it ahead of time, but that's part of this show is things take a while to install. Okay, there we go. Uninstalling numpy. Oh no. Oh boy, it's fiddling with my numpy. This is gonna be dangerous. Anytime my numpy gets fiddled with, bad things inevitably happen. Okay, successfully installed. Let me launch IPython. All right, this is MNIST. Let me just try this. Keras models import sequential using Theano backend. Yeah, that's what we're doing. And of course, I'm doing this without having checked what things changed, because I'm a horrible person. That's what happens. UDNN not available still. Makes me sad. Okay. That all seemed pretty standard. Matplotlib still works, I hope. We're gonna load up our data. Hopefully I don't have to reload it all in again. MNIST is all typical. 60,000 training samples, 10,000 test samples. That's good. We're not going to spend a lot of time looking at the new Keras, just enough to see if any of this changed. That was a quick compile. I like that. Alright, we fit the model. What is this? This is with 3 epochs I decided, apparently. Verbose equals 1. I gotta love me. The show accuracy argument is deprecated. Alright, good to know. Instead, you should pass the accuracy metric to the model at compile time. Interesting. I do want to know this information, so let me recompile the model. Metrics equal... I just pass a list, I guess. Show accuracy? Accuracy. Interesting. Alright, so we're going to recompile. Bam! That is fast compilation. I like it. And I appreciate that his code just told me it was deprecated, not that he's going to chew, not that it's chewing me out or throwing error. Look at that. Bam! 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 Validation accuracy, regular accuracy. That is pretty quick. Less than a second. Why do I feel like... I feel like I was doing stuff that was taking a lot longer than that. Maybe not. Maybe 1 second sounds about right. I love the verbose mode progress bar. This is so good. This is not climbing super high, but it's improving. Okay, that's cute. You get weights the same way? Can I look at the weights the same way? Let's find out. Takes a long time for me to go. Okay, here we go. Alright, so these are 128 neurons, right? Yeah, we got some interesting shapes in here. What is it? Like a little infinity shape from MNIST? That's funny. Some kind of cool blob shape and its cousin blob shape down here. Or potato shapes, whatever you like. Alright, well that's interesting. And for giggles, we will look at, these are the outputs. Yeah. Look at the outputs too, total size. Apparently I never fixed that business. So we're not going to look at that. Yeah, no, that doesn't even make sense. That's just going to be, W2 is just a 2-dimensional thing. W2? Oh, it's just an array. I love that. Oh, because I did the get weights. Right. If I just do plot.bcolor mesh of W2, that should show me what I want to see. Yeah, there we go. Here's the 128. Each row is one of the neurons, and each column here is one of the output classes. And different neurons activate different classes, as we expect. Okay. Nothing too fancy there. There's visualize util? Oh, I wonder if... I never got this working the way I wanted. I wonder if this is... Oh, can it import to Craft? What changed in visualize? Visualization. Show me, what are the options? Model visualization. Import plot. There's no to graph model anymore? Py.graph object, render yourself. Model to dot. Ah, okay. Show it in IPython notebook. Oh, does this mean I can sort of directly do this? I like that. Okay, so to graph is gone. That's fine. I don't need that anyway. What else is new? Model... Oh, model to dot is just how it changed. Model to dot. Okay, let's try that. Model to dot. And what are we doing here? Model to dot replaces to graph. Is that direct? Oh, this is a... This is not... Well, it's IPython. See if we can get away with this, even though I'm not in a notebook. We'll see what happens. I'm bold. I like to try things. Otherwise, it's the same. Just a name change, kind of. Yeah, of course. It's an object that I can't display, right? Cute. But we can do this silliness. Maybe we can't. SIO equals bytes.io. SIO. Alright, I must have cut and pasted some other code. Don't worry about it. Let's double check the custom activations doesn't work anymore. That's right. That was what I wanted. I read about this and I wanted to call it out specifically. So I used masked layer to make my custom activation work. But that's not how they work anymore. Where did he talk about this? Porting custom kernels. Yes, simply follow the instructions in this guide. Beautiful. Porting your custom kernels layers from Keras 0.3. Wow, it became 0.3 all the way to 1.0. That's impressive. So, what do we got? Keras engine topology layer, not mask layer. Okay. Mask layer has been removed. Goodbye, mask layer. Can I not? Is this not text? There we go. Okay. Tab new, and it's custom activations. And what do? Your layer inherits from this. Okay. So from this import layer. That makes a whole lot more sense, to be honest. The build method of the layer now receives an input shape argument instead of reading the input shape as self.input shape. So convert build self to build self, input shape. Where's build? Self input shape. There we go. And then I don't need to do that. Convert the output shape property to a method getOutputShape4. Make sure to remove the old output shape. Output shape? Do I not have an output shape for this? Am I a horrible person? Maybe. Output shape, same as the input. Alright. Does this set an output shape? Get output. Oh, that's even in old stuff. I don't get output. Do I need an output shape? I don't have an output shape property, that's fine. The layer's logic now lives in a call method, not underscore call. Your layer should not implement an under call. Convert the layer's get output self, train equals pulse into call self x mask equals none. Make sure to remove old get output method. Alright. Let's see what we can make do with that. Def x mask train. This is where I put train, I guess? No? Train equals false. Get input train. Get back there. X equals self.get input. Oh, no. Self.call. No, hang on. Does get input change at all? If your layer uses different behavior at training and test time, not rely on the Boolean flag train anymore. Alright, I think that's fine. Now there's train. Instead, put phase-specific statements inside calls to x equals k.inTrainPhase. E.g., here's dropout inside of the call method. Return. Hang on, let me make this bigger for folks and for me. K in train phase, k.dropout. So self.px. That's interesting. But what happens in this case during a testing phase? Does that just not call level? Like, how does it know? This is confusing. You know what? The faster thing to do might be to steal the code for advanced layers again. And again, it would be nice if... Do they have an example of make your own custom layer and I just totally didn't see it? Am I a blind person? Writing your own Keras layers. Maybe this is new. The existing Keras layers provide ample examples of how to implement almost anything. Never hesitate to read the source code. Well, that's what I did last time, so that's good to know. Build, here's the skeleton. There are only 3 methods you need to implement. Build, call, and get output shape for. Alright, hang on. You know what? Let's just come back here. Jeez, oh man, that's not what I wanted. Set paste, of course. Okay, much better. Set no paste. So we're going to implement it right here is where we're going to implement funky. Funky town, as in. Implements from layer. So input dim equals input shape, the same. Oh, you have to fiddle with this stuff, same as before. Initial weight value, whatever, that's fine. Set triangle rates. So this is just linear right now. Right. Funky town is what we want, though. We're all about that funky town. T.arctanx plus T.sinx. Right, because I was worried. I was making a custom activation layer. Right. So I don't even have any W in this, but we could make a W. Interesting. I didn't think about making a custom connective neuron layer. I was only thinking about a custom activation layer. So you could do something instead of just weights, but I don't really want to do weights. So goodbye. Initial weight values. I'm not worried about that. Not worried about that. And there's none of those. So that's all there is in build. Build is just, yeah, here's the shape. Okay. Self.output dim equals output dim. Yeah, that sounds fine to me. But what about? If you're using masking, I wasn't actually using it. You should not override. Perform incompatibility, yada yada yada. Okay. Built with Keras. Cool. Oh, tutorials and lessons. Hey! I never saw this. This isn't very thorough though. Sequence to sequence learning. Use the copy problem. Neural Turing machines. Don't try to write a full model on the first try. It's an important lesson. Doesn't he have other posts in his blog archives? Oh, that just goes here. How convolutional neural networks see the world. Keras, now running on TensorFlow. And that's the whole... That's all that. Okay. Well, that's that. It is what it is, I say. Can import mask layer. Alright, let's see what happens here. Just for some giggles. Because auto intent. I thought I had turned that off already. Apparently not. That was in the past. Oh, F. Alright, let me clear up some of this. I don't like to have holes in my empty blank lines because they screw up my pasting. Alright. Yeah, we'll do that. And then activation. Where's my actual custom activation here? Output dim. I really don't want to have to do custom harumph. So the output dim should probably be the same as the input dimension in activation layer. That would make a lot of sense. As in self.output dim equals input dim. Get output shape for. Like I shouldn't have to compute this, right? No. And I want that to be like whatever the input is, right? Alright. Clearly I should just look that up. Back on their source code. Keras, GitHub. We're gonna dive deep Not in the examples, actually. Although maybe we will look at some of this stuff. Because here's some good RNN stuff. Recently updated. Change optimizer, an example. Keras 1.0. Oh, deep dream in Keras. We might have to stop everything. Look at that. Sci-Fi 10 in Keras. This is good. This is good. I like this. I'm a fan. Addition RNN. Alright, we'll get that stuff in a second. Hang on. Actual Keras. This is a layer. This is advanced activation. Here we go. Yeah, so the leaky ReLU inherits from layer. Doesn't set the output stuff. Just need build, call, get output shape for. Oh, so init doesn't even have to have that thing. Doesn't need it. Forget that. Boom, it's gone. Forget it. Supports masking. I don't think we're worried about that. Call self s x max equals none. X and X. I do need some backend. Yeah, there we go. We got some Theano.tensor here going on. We're gonna need that. What we got? Git config. We don't have any of that. We just have base config. See, he doesn't implement. Does he implement build? He doesn't implement build here. This is where you define your weights. Okay. How to use non-trainable weights. Alright, so we don't have weights because this is an activation layer, so we don't need to worry about that. Call is where the layer's logic lives. That's good to see. That's spelled out. And get output shape for. In case your layer modifies the shape of its input, which in a typical neural network you would, but for an activation layer you're not going to. So I also don't need that. Git config, return dict base, yada 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 yada. Super leaky RU self.git. What? List, it grabs all the items that are part of it. Okay, we're not worried about it. We're not worried about that. So we just need the basic initialization and the call, which is what we have. I don't need build. I don't need get output shape. Alright, so this is actually considerably more simple than it was. So I'm a fan. See how that works. Okay. We got leaky ReLU there just for fun. Now where, oh where, did I actually call this? Did I? Oh my god. There we go. Activation Act 2. Right here is where I call it. Let's reshape some data. Let's run the model just because we can. Just because we can't. Funky object has no attribute built. Well, yeah, I know. That's kind of the point. Is this no longer how you use these? Is that the problem? Writing your own. Advanced activation. Yeah, do you show me an example with advanced activations? Looks like negatory. That's unfortunate. Funky object has no attribute built. Yay, I know. If not, self.built. Git config. This is because I didn't provide my own config because I'm a bad person. Alright, fine. Right, that is true. Git config. Actually, let me just steal the one from leaky ReLU. Steal the one from leaky ReLU up here. Perfect. Grab that. That is what I get for not being in insert mode. That is what I'm going to get for not being in paste mode. Things I forget every day. Okay. Base config, super leaky ReLU. No. Super funky. There we go. So let's try that. See if that runs. It did something. See if that goes. Funky object has no attribute built. Yeah, I'm well aware of that. Neither does yours, buddy. This doesn't have attribute built either. Just so you're aware. In fact, what if I said? Yeah, that, of course that works. Leaky rel U. Or does this... No, that's leaky rel U. Inherits, makes super calls to itself. What about my init? Is my init weird? Super... Ah! Not lair. Funky. Of course. Of course. Self.supports masking. Sure. No, let's not do that. Alright, let's try this one more time. Make a new model. Alright, now that actually added. Okay. Just very particular about how things get added. There we go. Right, show accuracy is deprecated. Oh, I really want to see that accuracy though. All about that accuracy. I mean, so basically now, instead of having it in the fitting part, I have to have it in the optimizer part. I assume that's an optimization thing, because this way the model knows, oh, I need to save that value and use it. Just like in TensorFlow, you can sort of, when you tell it what to evaluate, what to pull out of the graph. Metrics equals accuracy. Okay. Recompile. All right. Fast compilation. I like that. It's nice. Show me something. Come on. Come on, buddy. Run. You know you want to run. You know you want to do it. Show me something good. Show me something good. Ugh. Alright. Maybe it doesn't actually compile it when I do this compile, which is kind of annoying. Maybe it doesn't, yeah, it doesn't properly compile until you actually run the fit. Interesting. And I bet it's the first time you run it there. That's why this is so fast now, because it's not really compiling during the compile step. Compile just sort of does setup, I'm guessing. Because it doesn't, note that it doesn't grab the lock to compile until that point. And it's taken its good long time just getting started because it's doing the compilation. I don't even remember what I'm training on here. This is MNIST still? Okay. Well, this is terrible. Oh my goodness. This is absolutely horrendous. Why is my funky model so terrible? Who would have thought that arctan x plus sine of x is not a good activation function? Oh no. Oh well. Hello people in the chat. I hope this is entertaining to you. We are just finishing up checking out Keras 1. How many things do I have here? Got 1 layer, 2 layers, 3 layers. Oh, you know, I got 3 layers. W3, B3, there we go. Ah, there we go, perfect, okay. Nice, 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 nice. W1.shape. Alright, so that's good. That still works. 1 second here. Alright. So that's probably the limit of things I'm going to stare at for Keras 1.0 and much more, he says. So the upgrade, that actually worked. Took a little while. I upgraded my numpy in the process. It happens. We'll see if that breaks everything else. Visualization, we noticed. This changed to model to dot. That also happens. Not a big deal. Embedding I'm going to get to in a second. And the advanced activation, that changed a fair bit. I don't know if this is any easier than what it was before. I had just gotten used to what it was before, but this actually wasn't too bad to set up as we whipped it up right here. So Keras 1.0. Congratulations to Francois again. That's pretty cool. Alright, last week we were trying to study recurrent neural networks with Keras, and I'd like to get back to that. We've got this sort of sentence structure data set that we're trying to read and understand, but it was giving me some trouble, and I apparently have highlighted the word train everywhere. Choo-choo train. Okay. But now, at this moment, I see that there's some recurrent nets for this other stuff. Examples that are recently created. 10 days ago. You think I would have noticed this in the last week. Oh, Deep Dream. I so want to fiddle with this, though. Oh, tempting to run Deep Dream right now. Implementation of sequence-to-sequence learning. Input is... This looks like maybe my input. No, probably not. Okay. Baby RNN. Yeah. This is LSTM baseline. Keras QA. Interesting. Single supporting fact, 2 supporting fact, 3 supporting fact. I'm not sure what this is about. Towards AI complete question answering. Resources related to... Oh. Babi. Tokenize, parse stories. Does this actually call RNN? Print RNN embed send. Oh, this does, doesn't it? Ah. Sequential vocab size, embed hidden size, input length. What is embed hidden size in this? It's not saying. RNN. Embed hidden size. Merge. Whoa. This is... Oh, he's using two RNNs here. Right. So you might recall we have this context window of... Let me just load all this junk in. So we have it again. Well, let's see if the RNN stuff changes. Okay, that's good. We have this data set, which I'll get to in just a second, of sentences. Like, I want to fly from Boston at digit AM and arrive in Denver at digit in the morning. Of sort of queries people have put in that they want to understand. And the goal is sort of have the computer tokenize this into something that makes sense. Like, subject, verb, want to fly is sort of the verb, or go is probably how it would be done. From this place, time, and so that's sort of the goal we want to do. Not classify. We don't want to classify each word. I don't know. Maybe we do. I forget now. I don't remember now. I've already forgotten. This was not a super happy not a data set I was super happy with, but it was what I was able to pull up in a short amount of time. So we're taking a context window around each word. So we grab the word and its neighbors. We put the word in the center position here, and its neighbors on the left and right. So this is just the index of the word. So word 232 happens to be I. Word 542 happens to be want. The negative ones just mean that was necessary padding. Our longest sentence is 46 words. Wow, okay. That's a long run-on sentence, man. W5s is our window size with our context win. This should really be defined up here, so I don't go crazy. And the number of labels that we have, I think I was trying to figure that out. 128, yes. Because there's 127 token labels. What kind of word is this? Plus 1 for the padding, which is -1. TQDM is my progress bar, which I love so much. Bam, it was too fast, you didn't see it. That's okay. Oh, jeez, is this? Yeah, okay. Train W. That's a lot of stuff, yeah. So this is all the sentences broken up into their context window formats, of course. So here you see the -1, then you get the next window, the next window, the next window. So this is a sentence of like 10 words. Not too long here. And we're putting the token encodings into one-hot format, of course. So it's encoding whatever's in the center, right? So 439 here. I don't know what that kind of thing that's going to be, but that's fine. Right, it's whatever this second to last thing is, 127, which is probably like other, just a guess. Miscellaneous. So if we look at, is that a list? Oh, it is. Ugh. Test hot 0. Yeah, dot shape. So this is a sentence that's 18 long, and there's 100, of course, 128 classes, like we said before. The catch here is something that whatever I'm not understanding. So we start with these train X. Train W. So these are all of our W guys. And our indices are just, like, this is what word we have, but like, this is a number, but that's not actually indicative of the fact that this is 439, and this is 301, and this is 32. That doesn't bear any relation to each other. 301 isn't, this word isn't 10 times whatever this word is. That's, if it's like, I want to, that, these are just indicator values that happen, these are what the values happen to be. So I believe the embedding here is supposed to take our input values, these guys, and convert them into some kind of vector space that actually makes a little bit of sense. So it's going to take sort of our one-dimensional, maybe this one-dimensional thing, and put it in a two-dimensional space of a bunch of floats. And if it says, oh, well, this batch of 5 is vaguely equal to this. So I think that's what we want. I don't actually know, though. I gotta be honest. Let me just do this. Let me say model.summary. This is a good way to, in Keras, to... Oh, we gotta freaking compile a model now. Let me do that again. There we go. Ugh. Hang on. There we go. So it kind of annoys me that I compile when you first run it now. That's, not a big fan. Okay. Output shape is going to be 5 by 1024. Why is it 1024? What's the input shape? We don't know yet. Okay. Connected to embedding input. Alright. Right. It's 1024 out. Why is it... Is each word? Ugh. So embedding, I just don't have a good example to work from with this. Like, and of course all these examples. Here's an example. Embedding. And it says, vocab size, embed hidden size. What's the vocab size? I gotta go look these things up now. As usual. Vocab size. Vocab size, vocab size. Let's search up. Up. Length vocab plus 1. So that's what I'm doing. The length of my vocabulary plus 1. And you're doing embed hidden size. Embed hidden size. Story max length. Oh, maybe W isn't supposed to be 5. Sorry, maybe input length isn't 5. Input length is the longest message. What about that? Now model.summary. 46, 1024. Alright. So is the embedding taking my long bunch of messages and doing something else with them? Well, it didn't yell at me. Compiling doesn't take any time now, so that's no longer interesting. Because now I want to time the fitting. Now, but I don't have to time the fitting because that tells me how long it takes at the end. This will take a while to compile. Let's see if this does anything. User warning, show accuracy. Ah, burned if I show accuracy again. This is going to be... I appreciate that it's deprecated. I really do. Error when checking model target. The list of numpy arrays that you are passing to your model is not the size of the model expected. Expected to see 1 arrays, but instead got a following list of 4,978 arrays. Is that how long this is? Yes. Okay. Well, were you expecting to get one thing input here? Come on. You expect to see one array? Really? Alright, input length. What do you see for input length? Story max length. Vocab size, embed hidden size, and then where do you actually... Oh, add dropouts. Oh, you can merge in the two models. I didn't know about that. Merge. I'm going to have to check this out at some point. Some you just add them together. Oh, that's super cool. Training. X and XQ. Real cute there. Really cute. Model.evaluate. Oh, you can just do that. Groovy. You can do the validation split, right? I had like all these things about Keras that I sort of know, like, oh yeah, I knew you could do validation split in place, but I always forget. Okay, but model that. Alright, so X. Show me X. Vectorize stories. Great. Train, word index, story max length, query max length. So how do you vectorize stories? Vectorize stories. Data, word index, story max length, query max length. If I can't get the RNNs to work this week, I'm probably just going to pause on those until I can get a better understanding of this. Because this is just a little silly. I just want the simplest example of RNNs that works. Right? Let me spend 30 seconds looking. Recurrent Neural Network, simple example. Maybe I didn't search that because I was searching benchmark problem. With word embeddings, like again, this is, oh, this is because it's using simple RNN, isn't it? Simple recurrent neural network to feed with. Yeah, well, except it doesn't really work, buddy. Running the code, stopping criterion. At least they show me some Theano stuff there. Unreasonable effectiveness of recurrent neural networks cube. Recurrent neural networks in TensorFlow, which I would love to just steal some of that stuff. They do some wacky language modeling. They jump right into LSTMs. They don't actually explain what's going on behind the scenes a whole lot, though. They say, here's how you do LSTMs. All right, well that's fine. That's why I had someone request, and I think I'm gonna do a line-by-line tutorial of like one of the TensorFlow tutorials or something. Like maybe someone asked for fully feed connected .py or fully feed connected MLP, which just goes through MNIST, I think. But I wanted to do that because I know like you see weird constants showing up, and the comments never explain these fully. I mean, even in this, it was pretty good. Like vectorized stories. What's going on here? Maybe I could spend a lot of time. Let's not forget that the index 0 is reserved. Index 0 is reserved? I assume that's a +1, whereas I'm using... Yeah. Okay, that's fine. For story, query, answer. This is just a different kind of data set. That's why I'm getting burned here. Pad sequences. Expecting. Alright, you know what? Let me pass in 0 again. We'll see how that works. Ain't no thing. Oh, it's gotta recompile? Oh, that's awful! Is it, you have to recompile every time? I don't want that. Did I recompile it? No. Keras recompile 1.0. Optimizers, renit waits to avoid recompile. Last release 1.0. Let me check the issues. That seems weird. That shouldn't, like, even if this aired out, you wouldn't think it has to recompile every time it runs. That's really... Ugh. Why is this... I assume it's taking so long because I'm running something wrong. Issues. Summary a string. That would be really useful. Add option to change generator queue. Support TF axis ordering. Yeah, whatever. Coder decoder. How to transfer, no. Validation data are necessary. Visualizing the output of an intermediate layer. These are a lot of uninformed questions. Time distributed merge is removed. Filtering each channel separately. That's kind of interesting. Integrating Keras experiment, yada yada yada. Queries regarding sequence length, categorical accuracy. Alright, let me search. Recurrent dropout fails silently, masking not confused about classification problem with RNN. That is actually maybe helpful. Added fixed features with word embeddings. I have a bunch of time sequence data. I want to classify each 1-3 vector in a sequence of its classes. There's guys using LSTM. Every sample should be a sequence. Time step of 1 obviously doesn't make sense. Let's put your data on the 20,000 points. Yeah. Time distributed dense layer. Interesting. Like, this is frustrating because I understand how RNNs work, and it's not rocket science. It's just getting this set up to actually run. Okay, this is at least some vaguely useful output. Cannot reshape input of shape 8032 to shape 1, 46, 32. So do I need to like fill out my, what do you mean input shape of 32? Oh, where is it complaining, I guess? Model.summary. Can I do that whole thing? Output shape 46, 10, 24. That's, what is the 46? The 46 is as long as my sentence is. As long as my longest sentence is. That's every time. Okay, no, just every time I make any change. That's just annoying. I don't like that. Connect to embedding input 2. Why is it 2? Simple RNN 1, activation 11, dense 7. I don't know what these numbers mean here. I guess they're maybe just hashing or something. Output shape. Oh, because it tells me it's connected to this. Output shape is 32, 32, 128, 128, right. 46, 1024. This is still super strange. Like the simple RNN, expect more information than what I gave it. Inner in it, there's no input size, right? No, just output dimension. Dropout information. Alright, what about Keras simple RNN example? That's really what I'd love to see. In the examples folder, yeah, well, what about this addition RNN? Oh, this is using LSTMs. You know, I don't care if it's using LSTMs, if I can set it up the same dang way. 4 digits inverted, yada yada yada. Oh, gravy. Here we go. Sequential, RNN, hidden size. Input shape, max length chairs. Encode the input sequence using an RNN, producing an output of hidden size. Well, this is sequence to sequence, right? Trying to like reproduce your, or turn your like English phrase into French or something. Repeat vectors, that's not really what I want. So do I not want the embedding? Link chars. Maybe I don't want the embedding. What if I take out the embedding? What do you think? Take out the embedding? Take out the embedding. Of course. Yeah, input shape. Simple RNN doesn't even have an input shape though. Right? No. Simple RNN. So RNN? Maybe that's what I want? Maybe this is too complicated to be simple? Is that the problem? Again, we're running up against the time sink here, and this is taking too long to sort out. Can I import name RNN? Alright, what's the layer called now? Keras, documentation, recurrent layers, simple RNN. Oh, don't use recurrent. Yeah, well. Wait. Is there no more just RNN? Now everything is LSTM, GRU, or simple RNN. For the output is to be fed back to input. Yes, that is what I want. Inner init, which has no input shape? Or they all have input shape. They all have input shape. I'm assuming they all have input shape. Input shape equals, what was I gonna say? Whatever this silliness is, max length of my sentences, comma, length, my window, I guess. Yeah. Max length of my sentences is longest, comma, window length 5. There we go. Let's see what happens. Oh yeah, it totally runs. Compiles in half a second, of course. I wanted to throw all this stuff in. Like, I feel like I'm just inputting my data incorrectly. That it doesn't like that at all. But it's not clear what's going on here. It's maybe I should just give up and run one of these models. Tempted to run, what's this? Tempted to run sequence to sequence, even though it's not doing a classification problem. Deep Dream, or maybe I'll forget it and screw around with Deep Dream. Bad Trip, Dreamy. Maybe I fiddled with this one point before. This feels familiar. Deep Process, build the VGG16 network, yep. It's a standard image classification. You load the weights from a file. Continuity loss. You fiddle around with the loss function. You got a jitter. Oh no. Hang on. Okay. Sorry about that. I lost my screen, went into screensaver mode. Yeah. Expected to see 1 arrays, but instead got the following list of 40. Like, there is not a good simple example of just formatting your damn input. Oh, wait. What's this? This is for embedding. numpy.randit 1000, size 32, 10. Input an integer matrix of size. This. So do I need to expand every sentence to be as long as possible? As long as the longest? Because I thought that's what I got away from convolutional networks for. And that's why I wanted to use a recurrent net. That's what I thought anyway. That's what I thought. Simple, consume less, unroll, return sequence, go backwards. That's funny. TensorFlow warning, masking, simple RNN. Ah. Come on. Example. Okay, hang on. LSTM. Yeah, you know, this is better than nothing. 10,64. None is the batch dimension. Oh, I have to explicitly... No, okay. I don't have to explicitly tell it. But this is assuming like 10 long of a window size 64 in some case, in some sense. The following is identical. Input dimension equals 64. Input length equals 10. Interesting. Yeah, I don't know what's going on here. This is... I probably just have a fundamental misunderstanding of RNNs, or I haven't studied them enough. Failing to set up supposedly simple RNN. This sounds like what I'm trying to do. Trying to use a simple RNN to predict yada yada yada. So he's trying to do it here. This does not happen. Yeah, well. Using binary cross entropy, 5 units is very little, yada yada. Alright, hang on. Can this guy, is he able to even load his model? X-train. He gets a bunch of random numbers. Time points, features, bunch of features at each time point. Look, I have one feature at each time point. This is not rocket science. I mean, that he has random. Well, yeah, when you're just introducing random time, buddy. Okay. Interesting. Oh, and this is the author himself. Ah, bring that back. Bring that back. Look at the IMDb LSTM. You know what? Maybe I'll just look at IMDb LSTM examples. IMDb LSTM, and I'll just steal that. Instead of doing a recurrent net, we'll try to see what this says. Embedding. Max features. 128. Input length, max length. Jesus, why is everyone... Ugh. I would just send in all indicator variables for all of my guys. Oh, yeah, IMDb load data. Alright, you know what? Fine. Fine. We'll spend 2 seconds. I want to look at what the IMDb input data looks like. This is probably going to take a long ass time to read this in. I just want to know what it looks like. Max features not defined. F and A. Alright, a few seconds. I love these progress bars in Keras. That is so good. That is like the best thing ever. Okay. What does this stupid data even look like? That is the question. Just a bunch of numbers. What is the shape? 20,000 numbers? That's it? What? D-type? D-type is 0? What the hell is object? D-type object. So X-train. Oh. It's an array of lists. What a mess. What a mess. And I probably didn't even have to do this context window silliness myself. It was probably going to do that for me. Alright, where is the original stupid data? Train. Alright, there's the original stupid data. This is outrageous. Outrageous. Train.shape, or train is a list. Train is a tuple. Whatever. Train, and what's test look like? Or index. What's test? Yeah. I tell ya. Can't win here. Can't win. Max features, max length. So my longest thing is still the same. W is... What do we got? What do we got? Input equals max length. 128 is the number of things I want out. The maximum number of features. Well, this works differently though. 32 is how many things there I got. Oh no, I need my embedding back, of course. Hang on. That's why we have the embedding. Okay. Input length equals longest. Yeah, let's try that now. Yeah, we're gonna do that. We'll see what happens. And when this doesn't work, we will stop. And that's gonna be how it is. And it's got to compile now, because it's got to recompile everything. Hopefully that doesn't take forever. Oh, shit. Jazzbot. I want to, of course, put in the actual correct stuff there. What does train hot look like? Train hot. That's not what I want. That's not what I want. Test. We'll just change this for test. Okay. Now when this blows up in my face, in just a few moments, everyone checking. Data should be a NumPy array or list dict of NumPy arrays. Found. Did you not find a list of NumPy arrays? Is that not what you found? Train 0. Is it a one long? Train 0. What in the sauce? What is this? And what is length of train? 3, of course. Of course. Train 0 is really the magic. Okay. One more time. And then we're cutting it down. Alright. Expected to see one arrays, but instead got the following list of a whole bunch of arrays. I thought you wanted a bunch of arrays. Alright, I don't know what the deal is with this library and recurrent neural networks. I wish there was a simpler example just of showing you how the input works. Maybe I'll fight with the LSTMs, maybe I won't. I don't want to do complicated things, just given some data in a time series, try to put it in a class, or try to predict the next thing, or anything like that. But all the examples are kind of convoluted, which is strange for a simple RNN. That's the way it goes. Alright, but Keras 1.0 came out. We got to see how that worked. That was fun. New things happened. Next week, I think I'm going to take a break from this recurrent neural net stuff. I probably just have to do more reading on my own to understand what these problems are explicitly doing. It's frustrating that there are not well-described examples out there. So I might do a line-by-line example of something else. I might go back and do some stuff and do a model in like TensorFlow or something. People were asking about that. If you have something you want me to check out, always leave me a message, send me an email, hit me on Twitter. All that stuff is good. All right. You guys have a good night.